Hey, AP Chemistry guys for centigrams. This is Unit 1 work, and I'll see if I can break it into chapters for you so it's not a terribly long video. The first chapter here is going to be 1, and I'm not going to do a lot of work here because of the review and simplicity of it. Um, and I really don't think we need to, like quantitative and qualitative. We should know qualitative are things that are description or observations. Quantitative involve values, and so A would be quantitative, B would be qualitative. Physical and chemical properties are going to be things like boiling point and flammability. Again, those should be review. Physical or chemical properties, then A would be a chemical property that oxygen supports the combustion, and then D would be a physical property that lead is denser than aluminum, so you can use that to figure out the rest. Intensive versus extensive. Intensive properties does not depend on how much you have of the substance. Extensive does. So length and volume will depend on how much you have. And so that's going to be extensive, where temperature is an average of the entire system, so it does not matter how big the thing is. It's going to be an intensive property. Elements and compounds. Element is a single type of atom with then a unique set of properties, and a compound is going to be a combination of the elements bonded together. And so there you go. Prefixes, I'm not going to go over those. The big ones you need: mega, milli, kilo, and then the base unit. And so so if you have a meter, a kilo is 1,000 meters, and then a millimeter is going to be 1/1000th of a meter. So this is your thousands, and those are the two important ones. Bromine. Oh, okay. Here we go. Some density work, so we can actually do some of this. So we have density. Let's see here if I can get this organized. All right. So density is equal to grams per milliliter. And so if we have 586 grams and we have 188 milliliters, we can figure out the density of that substance. I have a calculator here I'm going to be using as well, so I don't have the answers, so you can see kind of how I do things. It is 3.12 grams per milliliter. Now if we go on to the next one, the density of ethanol has, so it gives us the density, 0.798 grams per milliliter. And we want to figure out the mass. So we have the milliliters down here, 17.4 milliliters. And we have then the mass up here, which is the grams. And we can just go ahead and cross multiply and divide. Equals 13.89 grams. We could also do it this way: 0.798 grams per milliliter. So we're going to put our 17.4 milliliters up here, and then we're looking for grams. I don't really like it this way because we're looking for something in the denominator, but it works out the same way. You're going to end up with that 13.9. If we did it a different way, let's see, if we did it 17.4 milliliters is what we have, and then we can go ahead and put the conversion factor next. 1 milliliter equals 0.798 grams. That'll get us our value. That's actually going to be better. Just ignore this. This was my fault. So we'll start with the given information here, and here's your conversion factor, and then nice arrow. And then we'll be able to figure it out that way. I kind of like this just because it's, I don't know, something that we're familiar with. with cross multiplication and division. So, all right, so let's see here if I can get a new document. All right, scientific notation, I really hope that we can do those. I'll do A and C. A would look like this, 2.7 times 10 to the minus 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have C, which would be 4.7 times 10 to the 1, 2, 3, 4. If you're not sure how to do scientific notation, look up some YouTube videos. There's going to be plenty of them out there. All right, and then the other way, we could do scientific notation. Let's look at 13, the conversion. So it seems kind of weird to do conversions in chemistry like this, but it helps us get used to that factor label that I did earlier with the density. And so there's always practice of conversions in the first couple chapters of college level chemistry books. So let's look at a couple of these. Again, I'm not going to do all of them. If we have A, that is 242 pounds into milligrams. Let's see here. This eraser is not good. All right. We're going to start with the given information, 242 pounds. And we're trying to get to milligrams. And I know a couple conversion factors off the top of my head that maybe you would have to look up. 1 pound is equal to 454 grams. And then we have 1,000 milligrams is equal to 1 gram. So I can go to grams and then milligrams. So 1 pound, is 454 grams. And then we have 1 gram is 1,000 milligrams. And we can get rid of the units here. They cancel. We end up with a value of a big one, 109868000. So if you have something like this, I'm just going to round it to 11. Let's see, 1, 2, 3, 4, 5, 6, 7. I think that's correct. So we could express this in scientific notation: 1.1 times 10 to the let's see, 1, 2, 3, 4, 5, 6, 7, 8 milligrams. There you go. Let's try one more. Oh, this is a good one. This is the centimeter cubed. So these are kind of weird. I'll show you how I like to do area or volume measurements and conversions. So this is B, 68.3 centimeters into cubic feet. Start with the centimeters. Again, some conversions. There are 2.54 centimeters in 1 inch, and there are 12 inches in 1 foot. These aren't things that I would expect you to know for the test, really, and so if you have conversions to do for the test, I'll give them to you. Now, that's not all of them. This one I would expect you to know. This one you would have to know. But like pounds to grams or centimeters to inches, that would be given to you. All right, so there's our centimeters. We're going to inches first. That's going to get messy. Okay, and this is centimeters cubed. Now, if we put a centimeter down here, we put 2.54 centimeters, 1 inch. It only cancels out one of the centimeters, so we need to do this 2 more times. Centimeter and centimeter. And so that cancels out centimeter cubed, 1, 2, 3. So 2.54, 2.54, 1 inch, 1 inch. I'm going to get to inches and then go back the other direction to the feet. Now, you can go ahead and put a cubed here, but you have to remember to cube that number, which when it's a label, it seems like you shouldn't have to do that. But when you're converting out of something, you do. All right, so we have that 68.3 divided by 2.54 gets us 4.17 inches. And that's going to be inches cubed. Let me double check that. Looks good. So there's our inches cubed, 4.17 inches cubed. And then again, the same thing. We have 12 inches, 1 foot, 12 inches, 1 foot, and 12 inches, 1 foot. So the inches cubed gets us to feet cubed. So divide by 12 cubed, 0.00, I'm going to have to run a room, 0.0024 feet cubed. Now if you're struggling with either C or D, that's what you need to make sure you do, is the cubing of the conversion factors. All right, let's go on to the last one, the challenge one, and see where we're at on that guy. This will take a little bit of room. All right, vanillin. It is based on vanilla, and the aroma of it humans can detect at very small quantities, and that is 2.0 times 10 to the minus 11th grams per liter of air. We have 50 grams of it, is equal to $112. Yeah, this stuff is not cheap. So determine the cost to supply an aircraft hangar so that you could smell it, that has a volume of 5.0 times 10 to the 7th feet cubed. So there's a lot of stuff going on here. That's what makes this problem difficult, is you have to figure out what to start with, basically. And I like to start with values. This here would be considered a conversion factor. This is also a conversion. Now, if we look at this question carefully, we're looking for money. That's the answer we want. So we first have to figure out how much, what volume this is in liters, so that we can convert that into grams. So, because this is a conversion that gets us to grams. Once we have grams, we can use this conversion to get us to money. Hope that makes sense. Here we go. 5.0 times 10 to the 7th feet cubed. Let's see how much I can get on one line here because this is going to take several conversion factors. And let's see, some other conversions that we are going to need. Again, 1 cubic centimeter is equal to 1 milliliter. That comes from cc's. If you ever hear on shows that they're going to give a patient 20 cc's of whatever, that's what that is, cubic centimeters. It's a milliliter. We also have our then 12 inches is equal to 1 centimeter, and then we have 1 foot is equal to 12 inches. This is wrong. This is 2.54 centimeters is equal to 1 inch. Sorry about that. This is what was needed next. That's garbage. All right, so I'm going to go feet first to inches. That way I can get to centimeters, and then milliliters, and then liters. So first, feet to inches. 1 foot, 12 inches. 1 foot, 12 inches. And 1 foot, 12 inches. Those go away. Now we're in cubic inches. Maybe I'll do it that way. Maybe I'll show you the different parts. All right. So that's going to get us into cubic inches. .64. There's the cubic inches. Now I can go into cubic centimeters. One inch. 1 inch. 1 inch. And this is 2.54 centimeters. 2.54 centimeters. 2.54 centimeters. Now again, you can just put a cube here and cube that value. It works the same. I like showing it out so you can see how the labels get canceled. There's 3 inches here that need to get canceled. 1 inch, 2 inch, 3 inches. That gets us centimeters times centimeters times centimeters. That gets us into our centimeters cubed. So times. Big numbers. 1.4 times 10 to the 12th. Something you're not seeing here. This value is rounded. Actually, this value isn't rounded, but this value is rounded. But for my next calculation, I'm going to use the unrounded value in my calculator to keep going. So I write down a rounded value because it's cumbersome to write out the whole thing, but I'll use the unrounded in the next step. 1.4 times 10 to the 12th cubic centimeters. Label that cubic centimeters is equal to 1.4. Times 10 to the 12th milliliters. So that's an important step. Now we're into the same kind of volume that the liters is, and that's what we're going to be using next. So we can go 1.4 times 10 to the 12th milliliters. 1,000 milliliters is 1 liter. That was way too much room there. Okay, so this gets us, should be, let me double check, to the 15th, or to the 9th. there you go. So there's our liters. Now we can get to grams, and I'm going to need a new page to continue this. So let me go ahead and move this over here. I know there's a lot of stuff going on. New. And we'll continue this over here. We have 1.4 times 10 to the 9th liters. There is 2.0 times 10 to the minus 11th grams in 1 liter. And then we have 50 grams is $112. Grams goes away, and that gets us our value, which, let's hold our breath here that I didn't make any stupid mistakes, times 2.0 times 10 to the minus 11th. I take that times 112, divide that by 50. Perfect. We get 0.0634 or 6.3 cents. All right, that one took a long time. So we're done here with chapter 1. I'll move on to chapter 2 in a different video.